Good afternoon, children of class 8th. Today we would be looking at the second part or the concluding part of the second chapter of chemistry, which is physical and chemical changes. Last time we saw the properties of physical change and chemical change and the physical and chemical reaction. This time we are going to concentrate on the difference between the physical change and the chemical change. And how do we differentiate between physical and chemical changes? Let us see them one by one, and this will also revise what we had studied in the first part of the video of the second chapter. First, physical change is a temporary change. It happens for a little time, like ice changing into water, and back water can be changed into ice. And then it is a permanent change. For chemical change, we see the difference is it is a permanent change. Then in physical change, we see no new substance is produced. But in chemical change, new substances with different properties are produced. Then we see the third difference. In physical change, there is no absorption or evolution of energy. Whereas in chemical change, if you remember when we saw the experiment of burning paper, then there is an evolution of energy in the form of heat or light. So in chemical change, energy is always evolved or absorbed. Then there is no change in mass. In physical change, we see the mass remains the same. But in chemical change, we see that the masses of the substances change. However, total mass remains unchanged. So we see in chemical change, like when paper was burned, the mass of paper was more than the mass of the ash that was left. Then the fifth difference is, in physical change, the physical properties of a substance change, but its composition does not change. The things it is made of does not change. And in chemical changes, we see there is a change in physical properties as well as in the composition of the substances. Then the sixth difference we see in physical change, it can be reversed by physical means. We saw that how we could heat water, liquid water, that changed to vapor, and vapor again on cooling changed back to water. But in chemical change, it can't be reversed by physical methods. It is an irreversible change, so it cannot be reversed by physical methods. Then let us see the chemical change. How do we define a chemical change? When one or more substances undergo a chemical change with the absorption or evolution of energy to give new substances, this change is called a chemical reaction. So chemical change, with the help of chemical change, we have defined what is chemical reaction. What is chemical reaction, children? When one or more substances undergo a chemical change with the absorption or evolution of energy to give new substances, this change is called a chemical reaction. Please learn this definition. Then we come to what are reactants and products. We see that the substances which get together to undergo chemical change are called reactants. Let us look in this example. We see that reactants AB and reactants CD. AB and CD, these are reactants, and so these get together to react. Then we see what are products. Products are new substances which are formed due to chemical change, and so are different in composition from the reactants. We see that what are products? These are the new substances which are formed due to chemical change. Okay, now we see that when a chemical reaction happens, then the bonds form or break. Now, what happens to the bonds in chemical reaction? During chemical reaction, old bonds. This was the old bond between the reactant AB and the reactant CD. So the bond between AB and the bond between CD, these old bonds broke. So we see during chemical reaction, old bonds in the reactants are broken and new bonds are formed, giving new substances called products. So we see that these bonds were broken, new bonds were made between A and D, giving a product AD, and C and B giving a product CB. Now let us take a live example of sodium chloride NaCl with silver nitrate AgNO3, and these two reactants, they break up, their bonds break up. Sodium, it combines with nitrate to give sodium nitrate, and silver Ag combines with chlorine to give silver chloride. So we see here that the bonds were broken to form new bonds, and this happens in chemical reaction. Then we see that there are some conditions under which chemical changes or chemical reactions take place. Let us look at these conditions one by one. The very first condition is close contact. The chemical reaction occurs when reacting substances are brought in close contact with each other. For this, we can grind them and we can make them finer. And when these reactants are ground and are made into powder, they react faster because they are in closer contact with each other. And so it gives a quick reaction. And we see sometimes the reactants, they are dissolved in a solvent like water so that the reaction would take place. Here we see the example of sodium which is put in water, and so a quick vigorous reaction takes place. Sodium hydroxide is formed and hydrogen gas is released. Now let us come to the second condition. The second condition of making a chemical reaction is the state of the reactants. What is the state of the reactants? Whether they are liquid or they are solid or they are gas. We know that the kinetic energy of molecules is maximum in gaseous state, and the kinetic energy is least in solids. This we read in the last chapter. We studied in the last chapter, if you remember, the number of collisions or hits between the molecules are maximum among the molecules of gases. Thus, reaction will be fastest when the reactants are in gaseous state. Let us quickly look at this example here. We see the reaction between nitrogen gas and hydrogen gas, which gives ammonia, NH3. So the state of reactants pays a great deal on what the product of the reaction is. Then let us come to the third condition, or heat. We see in this particular condition of chemical reaction, some reactions occur only by heating. As on heating, the temperature increases and this increases the number of collisions. So some reactants, it won't react without heating. And for example, we see here potassium chlorate. This is a reactant, and this potassium chlorate decomposes or breaks into its products only on heating. Likewise, we see iron and sulfur. These two reactants, they will react to give iron sulfide only on heating. So heat produces this chemical reaction. Let us quickly come to the next condition of chemical reaction, light. Light, we see some reactants, they react only when they are exposed to light. And what is light formed of? Light is formed of particles called photons. And that's why the reaction which happens in the presence of light are called photochemical reactions. For example, hydrogen gas and chlorine gas, they combine in diffuse sunlight to give hydrochloric acid. Then let us see another example. Oxygen is converted to ozone in ultraviolet light of the sun. So when the sun gives ultraviolet light, then oxygen in ultraviolet light produces ozone. Then we see photosynthesis, which is a very common example in plants, that carbon dioxide and water in the presence of sunlight and chlorophyll produces food in the form of glucose and gives out oxygen. Let us come to another condition of chemical reaction, which is pressure. Some reactions take place when we put high pressure on the reactants. Like when we put a pressure of 200 to 300 atmosphere on nitrogen and hydrogen gases, then these combine to produce ammonia, NH3. Likewise, another example is that of sulfur dioxide. When sulfur dioxide and oxygen, they are put under great pressure, then they produce sulfur trioxide and heat energy is given out. Then let us see another condition of chemical reaction. This condition is electricity. Some reactions take place only when electric current is passed through the reactants. Thus, these are called electrolytic reactions. So, we can define this reaction as electrolytic reactions are those reactions which are performed when electric current is passed through reactants to give products. Here, for example, we see water. Now, distilled water, if we pass electricity through distilled water, it will not decompose into hydrogen and oxygen. But when we add a little acid in water, it becomes acidulated water. And the acidulated water, in presence of electricity, it decomposes by passing electric current into hydrogen and oxygen gases. Then let us see the second last example of a condition. Catalysts. Catalysts are used to bring a change in chemical reaction. Now, what is a catalyst? It is a substance which can increase or decrease the rate of a chemical reaction or the speed of a chemical reaction without itself undergoing any change. So we see here in this example that potassium chlorate, this when treated with a catalyst manganese dioxide, this decomposes into potassium chloride and oxygen. Then let us see another thing which is used called promoter in a chemical reaction. Now, what is promoter? Promoter is a substance which increases the efficiency of a catalyst. The catalyst we saw either increased or decreased the speed or rate of chemical reaction, and promoter is a substance which increases the efficiency of a catalyst. Like in reaction of nitrogen with hydrogen, molybdenum acts as a promoter in manufacture of ammonia. Then let us see the last example of the condition of chemical reaction, concentration of reactants. With the increase in the concentration of reactants, the rate of reaction increases. And one reason could be because of concentration of reactants, there is an increase in number of collisions between the molecules of the reactants, and that is why the reaction increases. We can see here with some examples that there is a reactant A. This has got a concentration of 2, and likewise a reactant B, concentration of 2. Now these two with the concentration of 2 each, they produce quickly a chemical reaction. But when we increase the concentration of both the reactants A and B, then the concentration increases the reaction rate also. So we see that more of product is formed and the reaction rate increases. So children, hope you understood today's video, the last part, concluding part of chapter 2. So I would send you the assignment for this part of the chapter soon, and next time we will continue with the 4th chapter. Till then, wish you all the best.